Hello and welcome back to a brand new topic. Honestly, here we go. Gotta learn just some trigonometry. Trigonometry is the study of angles in right triangles. So, as you remember from our similarity work, you only need two angles to know that two triangles are similar. And mathematicians looked around for a while and they're like, you know what? If we have two right angles, we only need to know one more angle to establish that the two triangles are similar. And remember, establishing that two triangles are similar establishes a bunch of ratios that will hold constant. So this one's bigger, but as long as this angle is the same, let's say it's 37 degrees in all of these, then these three triangles are similar. And then it will establish some ratios. Like, for instance, the ratio of this side to the hypotenuse will be the same as this side to the hypotenuse. Hypotenuse. And of course, the ratio of the side to side, that'll be the scale factor. The ratio of the hypotenuse to the hypotenuse, that's the scale factor. But when you compare this ratio, the side to the hypotenuse, within these two that are similar, that ratio will hold constant. So let's say this is a, oh, what should I do? Oh gosh, I should have thought this through. Don't worry. 4, and this is a 5. Well, then this could be an 8, and this would be a 10. You'll notice that the ratio of this side to the hypotenuse is half in both cases. Okay, so all we need to do is establish that one angle is the same. I'll do a little one, a little baby one, as long as they're right triangles. So we already have one angle for free. But if you think about it, right angles happen everywhere. The floor, a wall, right angle. A road going the other way, right angles. Oops. Road going the other way, right angles. It's easy to make a right angle. The earth, a telephone pole. You know, right? There's right angles everywhere. So we just need one more angle, and then we can have a support wire that is similar from telephone pole to telephone pole, or whatever. Okay, so in the earlier example, I said this side to the hypotenuse, but here's the problem. There's two sides. So when I say side, that's funny, I wrote this instead of side. When I say side, do I mean this side or this side? And if I say the side that's opposite from the angle, well, what about this angle? That side's opposite of this angle. And what this shows us is that we need a reference angle. We need a reference angle. And we will have a reference angle all the time. Okay? Let's call this one A, B, C. B is the right angle. This one's, of course, always the hypotenuse, no matter what. Because the hypotenuse, remember, hypo meaning under and tenuse meaning tension. This is the side that's under tension from the other two sides. This is the diagonal line. And these two sides are holding it taut. That's what the word hypotenuse means. But if we are from the reference angle A, then this is the opposite, like we discussed earlier, opposite of A. The hypotenuse is opposite of the 90. This is the opposite of this reference angle. And then this side right here that's right next to the reference angle If only we had a word that means right next to. Oh, we do. It's called adjacent. Adjacent. That means right next to it. So if you and your friend are standing adjacent to one another, you'd be standing right next to each other. That's what the word adjacent means. And then that's the opposite. But wait, what if we were viewing things from C's point of view? Okay, I'm going to switch colors to the easiest color to see, yellow. So now from C's point of view, C is the reference. I'm switching the reference. This is the adjacent. And then now this is the opposite. See, when we switch reference angles, the opposite and the adjacent switch places. But you know what doesn't switch places? The hypotenuse. That one always stays there. Maybe I should draw a different one. Too many of the... There we go. There's the 90. So what's the hypotenuse? That's always the hypotenuse. You guys are good at that. And then which angle should be our reference angle? It's always one of the other two angles that we stand. Like let's say we're standing here at angle X. That over here will be the opposite of X. Opposite angle X. Opposite X. And this would be adjacent to X. Now sometimes when I say it's right next to the angle, some students are like, this one? Yeah, the hypotenuse is right next to the angle, the reference angle X, but the hypotenuse is the hypotenuse, and it always stays the hypotenuse. So the angle, the side rather, that is adjacent to the angle, the reference angle, but not the hypotenuse. Okay, and that's the lesson. That's it. That's all you got to know. So let's see here. Let's do a triangle. Whoa, it's upside down and crazy. Why is this so terrible? CBA. What is opposite C? 6. What is adjacent? I probably should have labeled them first. Adjacent C, 8. What's the hypotenuse? Uh-oh, I have to do the actual Pythagorean theorem? This is going to be 10. Yeah, you can always use the Pythagorean theorem. Where this is going, though... Oh, my word. What is it? This is defective. Someone please go back and count how many times I just broke the lead in the last 2 minutes. Where this is going, though, is you'll eventually just have one side and 2 angles. And because once we have 2 angles, let's say this is a 37. Once you have 2 angles, 90, 37, we of course know this last one. See, 90 plus 37 is 127. So 53. This has to be 53 degrees. Now, every single triangle in the world that has a 90, a 53, and a 37, they're all similar, which means their ratios are always the same between their sides. Well, we have one of the sides, so that means we can look up the ratio for this triangle, for the 90, 37, 53. And there'll be a number for us. You can look it up in a calculator or these old books called trig tables. And once you look up the special ratio, you'll be able to fill in the blank for the hypotenuse. And, well, we started with the 37, so let's call this the adjacent. You know, we can look up these ratios. So we only need one side and only 2 angles, and we can find all the things. That's where we're going. But to get there, we got to learn the names first, like opposite of C, adjacent to C. Oop, that's the adjacent to C, haha, because 10 is the hypotenuse because it's opposite the right angle. That's the 3 words, opposite, adjacent, and the hypotenuse never changes. Now, of course, we could switch this to what is opposite A? And then the answer is 8. See over here, opposite C is 6, but opposite A is the 8. How about adjacent A? 6. See, they switched places because we switched reference angles. That's all right. It's easy. The hypotenuse doesn't switch, though. It's always the hypotenuse. Okay, have fun. 10 minutes.